If a multiplicative function f is defined by f of n is equal to sigma d divides n f of d, then f is a multiplicative. Now proof: let m and n are relatively prime positive integers, that is, greatest common divisor of m and n is equal to 1. M and n have a canonical representation. N is equal to p1 raised to power k1 into p2 raised to power k2, so on, pr raised to power kr, and m is equal to q1 raised to power j1 into q2 raised to power j2, so on, qs raised to power js, where kr and js are the positive exponents of p1, p2 and pr, and q1, q2, so on, qs are all distinct prime. In fact, the positive divisors of d1 of n are just the numbers. d1 is equal to p1 raised to power g1 into p2 raised to power g2, so on, pr raised to power gr. For all the possible selection of the g's, 0 is less than equal to gl is less than equal to kl. Similarly, all the positive divisors of d2 of m are given by d2 is equal to q1 raised to power h1 into q2 raised to power h2, so on, qs raised to power hs. 0 is less than hl is less than j less than equal to jl. Now we observe that d1 runs through all the positive divisors of n, and d2 runs through all the positive divisors of m. Hence their product m into n runs through the value of d is equal to d1 into d2 is equal to p1 raised to power g1 into p2 raised to power g2, so on, pr raised to power gr into q1 raised to power h1 into q2 raised to power h2, so on, qs raised to power hs, where 0 is less than equal to gl is less than equal to kl, and 0 is less than hl is less than jl. But these are just all the positive divisors of m. N is equal to p1 raised to power k1 into p2 raised to power k2, so on, pr raised to power kr, q1 raised to into q1 raised to power j1 into q2 raised to power j2, so on, qs raised to power js. Equivalently, sigma d1 divides n and sigma d2 divides m. F of d1 into d2 is equal to sigma d divides m and f of d. Clearly, the greatest common divisor of d1 and d2 is 1. Hence, from f of m n is equal to sigma d divides m and f of d equals to sigma d divides n into sigma d divide d2 divides m. F of d1 d2 equals to sigma d1 divides n into sigma d2 divides m. F of d1 into f of d2 equals to sigma d1 divides n. F of d1 into sigma d2 divides m. F of d2 equals f of n into f of m.